6.1 Law of Sines. Alright, the whole deal with Law of Sines is how we draw our triangle here. Notice the little a is opposite the capital A. Notice the little c is opposite the big C. Notice little b is opposite the big B. That's key because of how the formula is written. Notice the formula is the side length a over the opposite angle, the sine of the opposite angle, the side length divided by sine of the opposite angle, the side length and the divided by the sine of the opposite angle. Notice this can be rewritten like this, where the sines are on top and the a, b's, and c's are on bottom. Very simple. We'll prove this in class, but for right now we're just going to work with it. Like example number 1. We've got this information. Notice we got this triangle. Later on, you'll just be given this information, and you've got to be able to come up with a triangle. Just remembering that A is opposite A, and C is opposite C, and B is opposite B. Okay, then just set up your values. Notice that my angle C is 102.3, and my segment C is unknown, and then my B's are known. So my side B is 27.4, and my sine of that angle is 28.7. Notice we're back to degree mode, and we're back to just solving basic geometry problems, but the trick here is that we're solving triangles that aren't 90 degrees. In fact, this one's obtuse. All right, I went ahead and typed this all in the calculator to let you know how we're doing this. Make sure you're in degree mode. Then I like to use the fraction when working this out. It's 27.4 times 102.3 and then divide by sine 28.7. And our answer is 57.74. Very simple. And with the law of sines, we can solve real-world problems because we're back to good old geometry stuff, where we can find the height of a pole or so forth from given values. Note that this angle is 90 degrees and this one's 8, which makes the total 98 degrees. And we're looking for how tall the pole is, which is A. Notice where we have the angle associated with A, capital A, and we have the side length 22, and from that we can use this angle knowing that this one's 98 and this one's 43. Let me do some cleanup. So we just do 180 minus 98, excuse me, and then minus 43, which I get to be 39 degrees. So this angle here is 39 degrees, which we can use in our law of sines. Notice our side length 22 is known. It's divided by the sine of the opposite angle, which is 39. And it's equal to my unknown side A divided by sine of 43. I showed you how to type this in the last problem, so I'm just going to go ahead and cross multiply and solve. I get my A to be roughly 23.84. And we are talking feet here. All right, these are some cases. It's called the ambiguous case. If you remember from proving triangles congruent, the side angle was not enough information to prove they're congruent, but it actually boils down to a few different cases. There is either 0 triangles, 1 triangle, or 2 triangles, and this is really all saying that. So no triangles, 1 triangle, 2, none, and 1. There's really no need to memorize these values in the table because once you're using the law of sines, you can run into a case algebraically or from the trigonometry to determine if it's possible or if there's 2 different values or if there's 1 value. And it really has to boil down to some values on the unit circle, which you really don't have to know. You can just do it by trial and error. I'll show you what I mean here. All right, let's do the single solution case, side angle. Notice these are our values. This is an angle, side. Not enough information to prove that 2 triangles are congruent, but it is possible with trigonometry to show no triangles, 1 triangle, or 2 triangles. So I'm just going to go ahead and set it up with the law of sines. And this is asking us to find the remaining sides and angles. Remember that to solve for B, we have to first solve for the sine B. And then we do the inverse sine from both sides. All right, from doing the law of sines and doing my inverse sine, I got my angle to be 21.4 degrees. Now, this table above, you could actually reason out and solve this with that, but I find that's a lot of memorization rather than some understanding. So let's assume for a second that this is the one of two possible values, because obviously if this is a true value where this yields a value in the calculator or from the concept of inverse sine, then there's at least one. Let's assume for a second that there's two values. If there's two values, then we're asking what angle goes with this ratio right here. That's what we're asking. So if we type in 12 sine 42 divided by 22, we get let me pull up my value. We get 0.36. Now if I was on the unit circle and I did 0.36, it's roughly here because 0.5 is the halfway mark, obviously. Or excuse me, square root of 2 over 2. So I can compare it. It's not really that big a deal. Square root of 2 over 2 is 0.7, so it's about half that value. So my 0.3, I already lost the value again, 0.3649 is roughly here. Now, that's the sine value. Remember, the sine value is the vertical distance. The other 0.36 whatever is about right there. Notice this right here is a reference angle, which is congruent to this one. In fact, this angle and this angle are called supplement, excuse me. So if I take 180 degrees, in fact, it would have been better to have said that, I apologize, 21.4 degrees. So this is 21.4 degrees in here, so which means this is 21.4, which means this larger angle right here is 180 minus 21.4. And I get 158, so minus 21.4, I get 158.6. Now, what we're doing here, because you might have lost me in the midst of all that, is we did the law of sines, and we found that there's at least one angle that makes this true. And then we have to assume for a second that maybe there's two possibilities. So if there's two possibilities, these two angles, this angle and the other possibility, have to be supplements. Notice that angle is a supplement of it. But if that is the angle, then 42 and 158.6 have to add up to be less than 180, which is obviously not the case. Since that's not the case, this is the only possibility. Now, that was a lot of talking, but reasoning out, once you understand it, it's really fast. So once we get the angle, we can use law of sines to find, so we have angle B is 21.4. We can subtract these two angles from 180 to get this angle, and we'll use law of sines again to find the side C. All right, if we need to show that there is no triangle, there's a way to do it from the table, but like I said, I like to steer away from a bunch of memorization if possible and like to focus on understanding. So in this case, I'm actually going to set it up with law of sines, assuming that it could be a triangle. So if it could, then I have sine of 85 divided by the opposite side of 15, set it equal to the, let's assume for a second that this does complete a triangle. If that is the case, then we can find the angle B right here, and that would be sine of B is equal to, or excuse me, over 25. By doing a cross multiply, you get, I cross multiply, but I let the sine B alone for a second. Remember that sine, when graphed, cannot go higher or lower than positive 1 or lower than negative 1. Notice this is greater than 1, which means it's outside of the range of sine, which means this is not possible. This is one way you could show not possible. All right, same kind of case as the last example. We can go ahead and assume that there is a triangle with these values. Notice there's no drawing associated with it. I like to just scribble out a drawing. I know it looks roughly equilateral. I really don't care. I'm just trying to get my A's, my B's, and my C's organized. But I really don't have to do this because it's just simply plugging into the formula. So my sine of angle A divided by the segment A is equal to the sine of angle B divided by segment B. So for right now, we're assuming there's at least one triangle. So I do my cross multiply, 31 sine 20.5, and I divide out the 12, and I get sine B is equal to 0.9047. That is within the range of sine, therefore there is an angle associated with that ratio. So B is equal to 64.78 degrees. Now, once you're done with this point, you know that there's at least one value. Let's assume for a second that there's another angle that's associated with this. As I showed you from before, this is the first possibility, and its supplement is the other possibility, so 180 minus that angle, which I get to be Let's call this B1 and let's call this B2. Let's assume for a second that it is possible. I take this 115.22 and I compare it to, well, if it is this angle, it can't be this one at the same time, so it's got to be this one. Let's compare it to 20.5. Notice 20.5 plus that angle is less than 180, which means that it is possible to have a triangle with these as the side, these as the angles. That's really all you need to say to show that there are two triangles. And if it says find the two triangles, you need to find the other side lengths using the other side C and you call it C1, assuming that you're going to use B1, and then C2 using B2. And then obviously the angles C1 and C2 associated with B1 and B2 respectively. All right, we'll talk about area in class, but I'll just say a few things about it here. Notice that all of these setups are side angle side format from geometry, where the angle is split. Notice A is in between the two sides B and C is in between A and B is in between A and C. Where this formula comes from requires a little bit of a proof. We'll do that in class, but using it's pretty simple. You just simply identify your values from side angle side and plug it into this formula like that. And we'll do some of those in class. That's it for this video.